So this section is about solving systems of equations. A system of equations is when you have two or more equations with two or more unknowns. So here in all of these we have two equations with x and y as both of our unknowns. So we will need to solve for x and solve for y. Depending on the system, there may be more than one solution or no solutions. We'll see some of those in our special cases, but it just depends on the types of equations that you're given. And a system, if you solve it graphically, would be where the two graphs intersect. So like here, this is a quadratic equation. It graphs as a parabola. This has a typo. It's supposed to be 2x minus y equals -1. That's a linear equation. So there we have a parabola with a line. We may end up with two intersection points. We may end up with no intersection points. It just kind of depends on where the parabola is and where the line is. We could have 0, 1, or 2. Just depends. So we'll solve it and see. The first one I'm going to solve by substitution just to show you an example of that. The second one I'll solve by elimination to show you an example of that. So I'm going to solve by substitution, and what that means is take either equation and solve it for x or y. And with this one, I'm going to choose to solve the second one for y. So I'll take and subtract 2x from both sides, and then divide everything by -1, which changes every sign. So y equals 1 plus 2x. Substitution says take that value that y equals and sub it into the other equation for y. So I'll have 3x squared plus 4x minus, and then that quantity equals 7. What that does is it gives me an equation with only x's in it. There are no y's left, and that's what I was looking for. So I'm going to solve for x by distributing the minus. And then combining like terms and subtracting the 7 over. I need to get everything on one side and have 0 left on the right in order to solve. So there's 2x minus 7. Alright, so here's what I have. It ends up being a quadratic equation because of the squared. With quadratics, we will solve by factoring. So I end up with two factors. I'll set each of them equal to 0 and solve. This factor gives me x equals 4/3, and that factor gives me x equals -2. Those are both the first numbers of the two ordered pairs that will be my solutions. I need an x value and a y value for each solution. So these are the x values. I need to go and find the y value. You can take these and plug them into the original equations, or like this equation that was a simplification of that second one. I'm going to choose to plug them into this one because I'm looking for a y value, and this one's solve for y, so it's the easiest. So I'll plug in 4/3 first. 1 plus 4/3 times 2, that'd be 1 plus 8/3, that would be 11/3. So when I plug in 4/3, I get 11/3. That's my first solution. Then I'll plug in -2. 1 plus -4 would be -3. So when I plug in -2, I get -3, and that would be my second solution. Next, I'm going to try solving one for with elimination. Example 2. Elimination means I'm going to try to add these two things together, the two equations together, and get something to eliminate. If I do it right away, I get 7x minus y equals 23. Nothing is eliminated, so I don't want to add them together yet. I want to force something to be eliminated. I'm going to focus on the y's because one's positive, one's negative, and I like that setup better. I'm thinking if I multiply the top by 4 and the bottom by 3, I can get a 12y on the top and a -12y on the bottom. Then when I add the equations together, the y's will cancel. So if I multiply this 4 all the way through, I get 20x plus 12y equals 36. If if I multiply the 3 all the way through, I get 6y minus 12y, 6x minus 12y equals 42. Now when I add them together, the y's will be eliminated. I get 26x equals 78. Divide both sides by x, and I get x equals 3. So there's only one solution on this one because these are two linear equations, two straight lines, so there's only one place where they meet. I'm going to take the x and plug it back in for x into either equation. I'm going to choose the top and see what I get. 5 times 3 would be 15, so I'll subtract 15 from both sides. And divide by 3, so I get y equals negative 2. So there's one solution on that one, and it's 3, negative 2. The special cases are when things happen that you're not really expecting, as far as it's not working out as nicely as these. So I'm going to try this one. I'm going to solve by elimination by multiplying the top by 2. I get 2x minus 4y equals 6. And when I do that and add them together, the x's cancel and the y's. So 0 equals 7. That's one thing that could happen, is both cancel when you only meant to cancel one. Since 0 doesn't equal 7, I would say there's no solution. Graphically, that just means that they never cross. They're parallel lines, so they never cross, so there's no intersection point, no solution. The other thing that could happen, I'll multiply the top by negative 2. Here, x's cancel, y's cancel, and we get 0 on the right. 0 equals 0, 0 is true. It means when you graph both of these, everything is true as far as they are the same line. They graph right on top of each other. So in this case, we would say there's infinite solutions. And the infinite solutions are all found on the line. So I'm just going to copy that top equation. Infinite solutions on the line. Anywhere on the line would be a point that would make both equations true.